Hello students, let's try to understand D and F block element, right? So a D block element in which last electron enters into the orbital are known as D block element. Except zinc, cadmium, mercury, all the D block elements are known as transition element as they have incompletely filled D orbital. Okay. So if you talk about the zinc and cadmium and Hg student, so it is having 3d10 and 4s2. It is having 4d10 and 5s2. 6d10 and 7s2. So what you are going to observe here, 5d10. What you are going to observe here, student, that is d10 configuration is there. That is a completely filled, so that they are not going to consider as a transition metal. Next one you can see, that is position in the periodic table. They are placed in the group 4 to 12, you know, 4 to 12 in this periodic table. 3 to 12, not 4 to 12. 4, 5, 6, 7, you know, period number 4, 5, 6, 7, they are period, and in group 3 to 12. Since they are present in between C and P, S and P block, S and P block. So their properties are lies between S and P block element. They're all the 40 elements are metal. So 3D series element are first transition series. 4D series element are second transition series. 5D series are third, and 6D series are the fourth transition series. 3D series is scandium to zinc 21 to 30. 4D cadmium to yttrium to cadmium 39 to 48. 5D lanthanum to hafnium, and 6D actinium to UUV. Okay. Now we are going to understand how to memorize first transition series. Scientists are very cruel. Mange fico nico jara. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. If we talk about the second transition series, how to memorize this one? So यारी जरा निभाना मौत तक, यारी जरा निभाना मौत तक, रुकावट राह में पड़े तो आग में कूद जाना. द इट्रियम, जर्कोनियम, नियोबियम, मोलिबेटनम, टेक्नीशियम, रूथियम, रोडियम, पैलेडियम, silver, cadmium. Now the next series is what is there, student? थर्ड ट्रांजिशन सीरीज. ला हफ्ता वरना रे, उससे इधर पिटाई और होगी. लेंथनम, हाफेनियम, टेंटलम, टंगस्टन, रिहीनियम, ऑस्मियम, इरिडियम, प्लैटिनम, सिल्वर, मरकरी. Okay. Then here is there the fourth transition series. रदरफोर्ड डूबा समुद्र में, बोरियम हंसा मत डर, रोएंट कापर. एक्टिनियम, एक्टिनियम, रदरफोर्डियम. डुबिलियम, सिबोर्जियम, बोरियम, सैसियम, मेरिटियम, डर्मेस्टियम, रोबर्ट्सटियम, and copernicium. So there are there. Memorize 6D series element. एक राइफल दवा, एक्टिनियम, रदरफोर्डियम, डुबिलियम. But that is not very much important that to memorize all. Physical properties. They are typical element. They are malleable, lustrous, tensile strength, ductility, malleability, high thermal and electrical conductivity are there. So melting point, if you talk about, student, so first transition series, then second, and then the third transition series. So melting point increases on moving down the group. Greater the enthalpy of atomization, greater is the melting point. 5D melting point more than 4D than 3D, enthalpy of atomization or order of boiling point, variation of atomic and ionic radii. So here is what is happening, student. That is, it is decreasing. Is scandium, titanium, vanadium, chromium, manganese. Then it is going to be constant iron, cobalt, nickel. Then increases zinc to copper. Region nuclear charge and screening effect. Z effective more than, so size decreases. Z effective more, so size decreases. Z effective more, so size, what is happening, decreases. Now second point, what they are saying, screening effect and Z also equal to radii equal. The screening effect more than Z effective, so radii increases. So due to lengthened contractions down the group, the radii of the 4D series and 5D series are quite equal. Ionization energy 5D, 3D, 4D. Order of ionization Hg, Zn. Okay. The ionization energy half filled, fully filled orbital are high. Introduction to transition metal except zinc, cadmium, Hd. DD transition possible, D1 to D9. Octahedral Eg greater than T2G, which will not show DD transition, zinc, cadmium, mercury, copper. Which will not show DD transition. Copper will show, this will not show. Atomic radii, it is decreasing then increasing. Decreases constant, increases. Region decreases more attraction, constant attraction, repulsion constant. Increases more repulsion. Formation of color, range visible spectra 3800 to 76,000, white light, Bibgyor. Why red color is used in the traffic light? Region for colored in complex dischargation and charge transfer. Ligand should be present for the splitting configuration, should be DD. When an electron from lower energy d orbital excited to higher energy d orbital, then the energy of excitant correspond to the frequency of light absorbed, the color absorbed corresponding to the complementary color of the light absorbed. Colored complex absorb radiation in the visible region. Colored ion giving the following Mn2 plus. Formation of complex compound. Complex compound are those in which the metal ions bind a number of anions or neutral molecule, giving complex series. For example, FeCN6, 3 minus, 4 minus. These are the region for formation of complex. They have a small radii, ionic radii. They have high effective nuclear charge. They have high ratio of ionic charge to ionic radius and availability of vacant d orbital for the formation of coordinate bond in the coordination compound. Catalytic properties of transition. The transition metal and their compounds are known for their catalytic activity. This activity is ascribed to their ability to accept multiple oxidation state to power complex. Catalysts increase rate of reaction region, empty d orbital, large surface area, variable oxidation state, ability to form complex. Scandium not act as a catalyst, never used. Titanium Ziegler not a catalyst used in polymerization to high density polythene for the ethene. TiCl4 plus triethyl aluminum. Vanadium B2O5 used as a catalyst contact process for the preparation of H2SO4. Okay, chromium Al2O3 plus Cr2O methyl into benzene. Manganese used catalytic for the production of oxygen. Alloy formation. When two or more metal combine to form compound is called alloy. Alloy are formed by metal whose atomic radii differ by not more than 50%. Alloy are generally solid. Bronze.